Welcome back. Water Drop here, your friendly mascot who makes learning science relatable by using water to explain science topics in an easy, understandable way. Let's take a look at the states of matter. States of matter, it's just a phase. So, the law of conservation of matter states that matter cannot be created or destroyed. It can only be changed from one form to another. For example, when solid ice changes to liquid water, the total amount of matter in a closed system will always remain the same, even during a chemical reaction. So, we'll get into that in our upcoming chemistry topics. So, hang on. And let's take a ride with a water molecule. So, what's the matter? What are the states of matter? And how do the states change? And how can water drop help to clarify states of matter and phase changes? So, let's start with what do you know about the states of matter? There are four naturally occurring states of matter: solids, liquids, gases, plasma. Did you know that the newest stages are man made in a laboratory under extreme conditions, such as the Bose Einstein condensates, time crystals? Now that's worth saying, wow. So, water is one of the few substances on Earth that can be found basically in all three states: solids, liquids, and even gases. So, water can be found as solid in icebergs, snow, and glaciers, as a liquid in the seas, the oceans, and rivers, lakes, as a gas in the atmosphere. And these changing states are driven by, yep, the sun. So here's a water drop moment. Just to recap, water is a substance that's made up of hydrogen and oxygen, and it can take the form of a solid, liquid, or gas. And just a reminder that about 71% of the Earth's surface is covered by water. So here's your moment of chemistry. Let's break it down. All matter is made up of atoms, which in turn is made up of protons, neutrons, and electrons. Atoms join together to form molecules. Molecules are the building blocks of all types of matter. So atoms and molecules are held together by a type of potential energy known as chemical energy. So in our water molecule, we have hydrogen, oxygen, and that forms our happy little water molecule. Now let's talk a little bit of physics. Potential energy is the stored energy an object possesses due to its position, configuration, or state within a system, which has the potential to be converted into another form of energy, like kinetic energy. When conditions change, essentially, it's stored energy waiting to be released based on its current position or arrangement. And kinetic energy is that energy an object possesses due to its motion, meaning it is the energy of movement. Essentially, any object that is moving has kinetic energy, and the amount depends on its mass and velocity. So even though we don't see it, matter is in constant motion. Solids are particles that are packed closely together and don't move much. Electrons are constantly in motion, so the atoms have a small vibration but are fixed in position. Thus, they have a very low kinetic energy. Solids do not conform to the shape of a container that they are placed in. Solids also have a high density, meaning the particles are closely packed together. Now, how about liquids? Liquids are particles that are not as densely packed as solids, and so they can move around each other easily and do not have a definite shape. So liquids can conform to the shape of the container that holds it. Like solids, most liquids have a lower density, and liquids are incredibly difficult to compress. And here comes the gas. Now, these particles have a large amount of space between them and have high kinetic energy. Without confinement, these particles of a gas will spread out indefinitely. If confined, the particles of a gas will spread out to fill its container. If a gas is put under pressure, by reducing the volume of its container, the space between the particles will decrease and the gas is compressed, like in soda, a helium tank, or a filled balloon. So watch our little water molecules spread out as gas. So what are some examples of the four states of matter around you? Include a photo example in your digital or handwritten journal. Plasma. It's not a common state of matter on Earth, but we see it every day. And it is probably the most common in the universe. Stars like the sun are basically superheated balls of plasma, made up of highly charged particles with extremely high kinetic energy. The noble gases, helium, neon, argon, krypton, xenon, and radon, are often used to make glowing signs by using electricity to ionize them to the plasma state. The addition or subtraction of heat energy to matter causes a change of state. Thermal energy, which is heat, added to liquid water causes it to change to steam or water vapor, the gas. Removing heat from liquid water causes it to turn back to ice. So physical changes can also be caused by motion and pressure. I'm sure you have observed the phase changes that substances undergo when changing from one state to another. We've all played with dry ice, right? That's sublimation. That's when a solid goes directly to a gas. And I know we've all seen melting. You put that cup of ice into a liquid, and you will see that that solid ice, the particles gain energy and break away from each other to form a liquid. So in this example, you'll see that this cup of dark liquid became a little paler because the ice is melting. Freezing is the opposite effect to melting. Heat energy is removed from the particles, causing less energy, and the particles get closer together. Vaporization, when a liquid changes to a gas by adding heat to the liquid, and condensation occurs when a gas changes to a liquid due to its particles just losing heat energy. Deposition. Sometimes you might wake up, especially when it becomes very cold, and you see that that gas converts to a solid, and you'll see maybe ice crystals on the window pane. So latent heat is the heat obtained by water molecules as they transition from solid, ice in our example, to liquid, water, or to water vapor, a gas. Now we're talking phase changes, right? So the phase change diagram is a graphical representation showing how temperature changes substances from one state to another. As heat is added, solids melt, then change them to liquid, and then ultimately gas. The temperature over time graph demonstrates that as the temperature increases over time, the substance changes states. Temperature is the measurement of the average movement of the particles or molecules. An increase in temperature means the water molecules in this case are moving faster, and each horizontal line or plateau, for example, when the ice cube is melting, the solid is changing to liquid, and then when it's boiling, the liquid is changing to gas, and you can easily see this movement when boiling a pot of water. So during the water cycle on Earth, the heat is released when the water molecules condense back to liquid or solid, creating cloud droplets and various forms of precipitation like rain, snow, sleet, or hail, any form of water that falls from clouds. So the next time you drink a glass of water or go for a swim, think of all the states of matter and phase changes a water drop could have traveled through on its journey to you. So, as a quick recap, there are four states of matter: solid, liquid, gas, and plasma. Energy is needed to move between the different states of matter. And water is a common example of a substance that can easily be observed and manipulated on Earth in the form of a solid, liquid, and gas. Don't forget to like and subscribe for more adventures with Waterdrop as we study Earth, life, and physical science topics. And the best way to remember something is putting it into action. So send us your photos or drawings of states of matter around you for consideration to be featured in an upcoming video, and you may see your image and hear your name called out. Just email us at getsciencewithwaterdrop@gmail.com. Don't forget to like and subscribe to our Get Science with Waterdrop channel.